So as we continue to look at our converting back and forth between logs and exponentials, here are a few properties, okay? And these are going to come up over and over as we continue working with logs. So you kind of want to get to a point where you memorize them, but if you just think about converting back and forth between logs and exponentials, even if you kind of forget them and don't have them memorized, you'll stumble across these results just by knowing how to convert back and forth, okay? So what happens is anytime you have an argument of 1, so log base b of 1, that is always going to equal 0, okay? And it doesn't matter whether it's log base b of 1, log base 3 of 1, log base 18 of 1, log base 5 of 1. If you have a 1 in the argument position, that whole thing is going to equal 0. And the reason for that is if you were to convert it to an exponential, your b would be the base of the exponent, your 0 would be the exponent, and the 1 would be over on the other side. Remember, the whole point of logs is to get the exponent by itself. So what's over here by itself in log form is our exponent. And if we raise anything to the 0, we always get 1, okay? So, for instance, 5 to the 0 is 1, 8 to the 0 is 1. Anytime we raise something to the 0, we get 1. So anytime we see a 1 in the argument position, we know that whole thing is worth 0. Okay, so let's look through this little group right here. Do we see anything where the argument is 1? Yes, right here. So I know this is going to be 0. Okay, but if you didn't, you could picture converting it to an exponential. 273 to the something has to equal 1. Oh, that's going to be 0. Okay, so anytime that argument is 1, we know the whole thing equals 0. Here's another one where the argument is 1, so we know the whole thing equals 0. Okay? All right, another property is that if your base and your argument are the same thing, it equals 1. Now think about why that's true. Base of the log is the base of the exponent. So this base right here, b, raised to the 1 has to equal the argument of b. Well, yeah, anything raised to the 1 power is itself. So if I had 8 to the 1, I get 8. If I had 4 to the 1, I get 4. Okay? So that's what happens when your base and your argument are the same thing. So let's look. Do we see any where the base and the argument are the same thing? Yes, we do, right here. Okay, this base and argument are the same thing, so that whole thing is 1. Okay? If you weren't sure, you could certainly type it in a calculator. Math, arrow down to log base 19 of the argument 19, and we get 1. Remember, if you didn't have an 84 and you're using an 83, you would have to type log of 19, which was our argument, divided by the log of the base, which is 19. And of course you get, oh, I had an extra parenthesis there. That's why. And of course you get 1. Oops. Oh, because I did times instead of divided by. Log 19 divided by log 19. It would help if I did divide, right? And then I would get my 1, okay? Number 20, you may not recognize this at first, that the base is 10, but this base is 10. So here's a case where a base and the argument are the same thing, so that works out to be 1. Same thing here. I know they only wrote e once, but doesn't this mean log base e of e? So the base and the argument are the same, so that's going to equal a 1, okay? Next property here. Anytime you can have exponents on an argument, so their argument here was b to the x, you can have an exponent in an argument, okay? But if you converted this to an exponential, it would be this base right down here, base of the exponents, the base of the log, raised to the x has to equal the argument, which is b of x. Well, yeah, that's true. So what happens is anytime your base and your argument are the same, except your argument has an exponent, it reduces down to just that exponent, okay? What we're going to see later in the next section is that if you have an exponent on an argument, that exponent can come down front. So you would have x times log base b of b, and then we just learned that when your base and your argument are the same, that cancels out to leave just 1. So you've got x times 1, which is x. So that's another way to think about it, but that's why that happens, okay? Do we have any of those? Why, yes, we do. These are both 30, okay, the base and the argument, so that 10 will come down front, and it's just plain old 10. You could type it in a calculator, okay? If you wanted to, you could say, well, 30 to the whatever's over here has to equal this argument of 30 to the 10. So, of course, it had to be a 10 up there. That's another way you could do that, okay? Same thing here. I know it doesn't necessarily look like it, but remember there's a base of e down here. So this base e and this base e are the same. It's going to leave us with just the negative 12, okay? And then the last property that we have here, this one on the left is an exponential. I know it says log in it, but it's really an exponential, okay? Something is raised to an exponent, but there is a log in that exponent, okay? But notice the base, this base right here, and the base of this log are the same, so it leaves us with just that x, okay? Again, if you were to convert this to a log, you'd have a log base b of whatever's over here has to equal this exponent log base b of x. So that does have to work. We do have to have an x over here. So notice this exponent right here, even though they didn't write it, I'm sorry, this log right here, even though they didn't write it, this base is 10. So that means since this base and this base are the same, we're left with just 14. If you wanted to check in your calculator, you could. 10 to the log of 14, it's implied base 10 there. And sure enough, we get a 14. So you can type these in. And same thing here. This 8 and 8 are the same, so it would leave us with just the 5. Okay? We will get more practice with those properties, but it's a good idea to be practicing them. And it is nice when it's in a format that you can just type in your calculator. Okay? Okay, next group. They just ask us to convert. Some of them are logs. Some of them are exponentials. They just want us to convert the other way. Okay? This one's a log, so if we're going to convert, it'll be an exponential. Base of the exponent's the base of the log, so 5 to the second will equal 25. Okay. Hopefully you knew that was true. Hopefully you kind of just use the numbers to know that should work out to be 5 squared is 25. But keep in mind, the whole point of logs is to get exponent by itself, so the 2 must have been in the exponent position. The reason I want you to be able to do this is, what if it was like a equals log base b of c? These are not numbers that you know how they work out. But you could still convert. You could say, oh, the base is b, it's got to be raised to the a, and it's got to equal c. So we need to be able to do that even if it's not numbers that we recognize, like 5 and squared and 25. Okay? But it is nice when they are numbers because you're able to check yourself and make sure that you knew the correct way to move everything around. Okay? This one's an exponential. We can convert it to a log. Log base 3 of 1 over 81 has to equal the negative 4. Okay? Again, remember when you convert to a log, the whole point of logs is to get the exponent by itself. So the negative 4 exponent is what was by itself. Okay? All right. This is an exponential. So to convert it, we'll make it a log. Log base 10 of 1,000 equals 3. Now, I didn't write the 10 because if the base is 10, we get to leave it off. So I didn't have to put that 10. It's implied. Okay? All right. Next one here. This is a log, so we'll convert to an exponential. 2 to the 4th power equals the x. This is not one that we can check. We can't type this in our calculator and check it, so we've just got to think, hey, do we know how to convert everything? And we did. Now, I would point out, what's going to happen a little bit later in the chapter is they're going to ask you to solve this equation. They're going to give you this log equation and say, hey, figure out what x is. And you're like, well, I don't know. But once we convert to exponential form, could you work out 2 to the 4th and then figure out what x is? Well, yeah, you could. 2 to the 4th power is, let's see, 4 little 2's multiplied together. 2 times 2 is 4, times another 2 is 8, times another 2 is 16. So this one's x is going to actually be 16. You couldn't necessarily solve it in log form, but you could once you convert it to exponential. And that's kind of the point why we need to be able to convert back and forth for what's coming ahead later. Okay? Same idea here. If they ask you to solve this equation and figure out what x is, some of you may be able to go, oh yeah, x has to be 2 because 5 squared is 25. And that's great. But if you didn't know that, you could convert to a log. Log base 5 of 25 has to equal x. Okay? And now you could type this in your calculator. You could say, oh, let me go to log base and tell it I want log base 5 of 25, and it'll tell you that x had to be 2 over here. Okay, so we need to be able to convert back and forth so that later in the chapter we can solve some equations that involve logarithms and exponentials. Okay. This one, obviously, if you were solving for x, you could type this in your calculator, but you could probably, figure it out on your own. 7 to the x has to be 49, and I bet you could figure out, oh yeah, x has to be 2. Okay? They don't ask you to solve it, they just wanted us to convert, but we're kind of gearing up for that. This is an exponential, so we'll convert to a log. Log base 49 of 7 equals x. Remember, the whole point of a log is to get the exponent by itself. So if you didn't know what x was supposed to be, now that we're in log form, you could type this in your calculator and it would tell you what x had to be. Okay? All right, this is another exponential. So to convert, we'll convert to log form. Log base e of 8 would equal x. But remember, we never write log base e. If you want to write log base e, instead of that, we put ln. So ln of 8 equals x. And if you wanted to know what x was, you could type ln 8 in your calculator and it would tell you. Okay. This is a log, so we'll convert to exponential. X squared is 9. Okay. And of course, now you could probably solve that equation for x. You would go, oh, x is 3 or negative 3, and you could solve it. But you might not have known that when it was in log form. Another exponential, let's convert to log. Log base 5 of 1/5 equals x. Okay? All right. Next group, evaluate. Evaluate means work it out. Get a single number answer. Okay? Now, we could type these in calculators. Okay? We could type every one of them in a calculator. But let's see if we can do it without the calculator just for our own practice. Okay? So log of 10,000 equals something. Okay? Well, they don't write it, but we know the base here is 10. So 10 to the something has to equal 10,000. I wonder what that exponent is. Well, 10 to the second is 100. 10 to the third is 1,000. I bet you it's 4. 10 to the fourth is 10,000. Okay? And so that's great. We know what the answer is. If you struggled with that, you could type log 10,000 in your calculator, and it would tell you that the answer is 4. But I would like for you to try them on your own and not rely too much on the calculator just for practice, okay? The base here is 10, so 10 to the something has to equal 10. I bet that exponent is 1, okay? And remember, one of our properties was that if your base and your exponent are the same, it works out to be 1, and that's exactly what was happening here, okay? Log, implied base 10, they don't tell us, but we know it's there. 10 to the something has to equal 1/10. Well, let's see, how do I just send the 10 down to the denominator? That's by making it a -1. Okay? And then log 0. Let's type that in the calculator and see what we get. In the calculator, when we type in log 0, it gives us an error message. Okay? And we go, wait, what? What happened? Did I do something wrong? No. But remember how we said in the other video that the argument must be positive. This argument is 0. We can't work it unless the argument is positive. Okay? So this one is not real. This is a non-real answer. Okay? Error message. Okay? So I'm going to say not real here because arguments must be positive. If you do not have a positive argument, that's not a real answer. It's not going to work out. Okay? All right. So 10 to the something has to equal 100. That's going to be a squared right there. 10 to the something has to equal 1. Well, if I raise something to the 0, I get 1. And remember, that was one of our properties. If you have an argument of 1, it's worth 0. And that's exactly what happened here. Okay? 10 to the something has to equal 1 over 100. Well, 10 squared would give me 100, but I need to stick that 100 on the bottom. So I bet this is a -2. Excuse me. But if you needed to type that in your calculator, you could. Log 1 over 100. And sure enough, we get our -2. Okay? And then this last one in this little group here is another not real. It's another imaginary one or just not possible, not to work out, because we can't have a negative argument. Okay? No negative arguments. Okay. All right, some other ones here. Now notice all of these had a base 10. They didn't write the 10, but we knew it was there. This next group, they have other numbers in the base position. Okay. All right, so 6 to the something has to be 36. Oh, 2. Okay, so that one's going to be 2. If you needed to type these in your calculator, you could. Remember math, arrow down to log base, and you can type those in. I would like for you to try to do them on your own without typing them in the calculator except for checking purposes, just for practice. Remember, if you have an 83, you don't have that log base feature. You have to type log 36 divided by log 6, and then it will work out for you, okay? And we'll learn in the next, in section 4.4, why that technique works if you have an 83, okay? Next one here, 3 to the something equals 1/3. Okay, well, I need to send the 3 down to the bottom, so I bet that exponent's a -1. Okay. 3 to the something has to be 27. I know that's 3. 3 times 3 is 9, times another 3 is 27. 2 to the something equals 1/4. Well, I know 2 squared would make 4, and I need a negative to send it in the bottom. So log base 2 of 1/4 is -2. 2 to the something is 16. I know that's 4. 2 to the 4th power is 16. 4 to the something is 2. I bet that's square root. Square root of 4 is 2, so I bet that's raised to the 1/2. Okay. Let's see here. Log base 3 of 3, that's a 1. Remember, anytime that the base and the argument were the same, but if you weren't sure, 3 to the something equals 3. That exponent is a 1. 7 to the something has to equal a 1. I bet that exponent was 0. Okay, remember, anytime the argument is 1, we get a 0. This is that other property, but if you forgot the property, 7 to the something has to equal 7 squared. Oh, I bet it's a 2. But the property that we're using, remember, when your base and argument are the same except for that exponent, your answer is just the exponent, okay? Or what happens is that exponent comes down front. This is really what's happening. And then your argument and base are the same, so that leaves a 1. 1 times 2 is 2. Okay. Here's another one where the base and the argument are the same. 9 to the something has to equal 9. So when your base and argument are the same, it equals 1. Here's one where the argument is a 1. 8 to the something has to equal 1. That means we had a 0. When your argument is 1, your answer there is 0. And here's another one where that 3 would come down front. And you'd have 3 times log base 5 of 5, and those are the same. So it leaves us with just the 3. Okay? You'll get better at these. You've got to keep practicing them. Okay? Your calculator can help. You could have typed all those in your calculator, and it would help you. But I would like you to try to practice in case if it was a test or something, you just had variables. And you couldn't type it in. Okay. Another one here. 4 to the something equals 4. Okay, well, that would be 1. Another one with an argument of 1, so that's going to be a 0. 5 to the 0 would get you the 1. And here's another one where the base and the argument are the same, so that exponent would come down front, and you get the 1/2. Again, you could type all of those in a calculator. Okay? And then the last group here, they do want you to use a calculator. These are going to be logs that don't work out to be nice, pretty numbers. They always work out to be decimals, so you will have to use your calculator. Okay? In other words, 10 to the something equals 30,000. That is not going to be a nice whole number, okay? So you're going to have to type that one in, okay? So log 30,000, and they told us to round to 3 decimals, so 4.477. Log 3 is the 0.477. I bet you know this one. Hopefully you know that one. Log 1. Remember, that's going to be a 0. Anytime our argument is 1, we get a 0. Here's one that doesn't exist, right? Remember, your argument has to be a positive number. Okay, so this one's an error message. Does not exist because you must have a positive argument. The argument's the number in that position right there. And if you typed it in your calculator, it would give you an error message. Notice this one, it looks a lot like the one above it, log 30,000, but it's ln 30,000. So that is a different base, so the answer is going to come out different. Okay, it would be e to the something equals 30,000. So the answer is going to be a little bit different. ln 30,000 And we got 10.309 if we round to 3 decimal places. ln of 0.3 is negative 1.204 when we round to 3 decimal places. Here's one of our little properties that we just learned. The base here and the argument are the same. They're both e, so it's going to leave us with just the 5. But if you didn't know that, you could type it in, and it would give you the 5. And then here's another one. It's an error. It doesn't work because you can't have a negative argument. We must have positive arguments. So that one wouldn't work out either. You just got to be on the lookout for that. Okay. These log properties and working with logs, we'll get better at them. We'll see some more log properties in 4.4, but just keep working through those. You'll get better at them.